Here I'm going to look at balancing equations. Now the first thing to note is probably there are a few reactions that we're expected to know what happens to the reactants after they've reacted. So the first would be if you take an acid and a base, well, it's expected that the acid and base react to form salt and water. For more on that, have a look at the acid section on the website, rmcstudy.ie. So hydrochloric acid reacts with calcium hydroxide to produce water and calcium chloride. Calcium coming from the base and the chloride coming from the negative ion in the acid. So rule number one for this process, after you've got the word equation written out, what you need to do is write down the chemical formula of each species, the correct chemical formula. Find out more on the chemical formula, have a look at the video in the previous section. So hydrochloric acid, we know that it's an acid, so it produces hydrogen ions, and the negative ion there is the chloride, so it's HCl. I know the formula is HCl because hydrogen gives away one electron to form H+, and Cl will take one electron to form Cl-. Else you can just learn that the formula for hydrochloric acid is HCl. Remember, have a look at the acids section to find more about the acids, but as a molecule that's just hydrogen chloride, a covalent bond, but when it's added to water we remember that it forms ions, so that's a H+ ion and that's a Cl-. We know the charges are equal but opposite, so the formula is just HCl. Next formula is calcium hydroxide. Well, I know calcium's in group 2, so it's a Ca2+, and a hydroxide ion is my polyatomic ion, which is OH-. Okay, to get the formula right, then I know I need to have the charges equal but opposite, so therefore the formula for calcium hydroxide is Ca brackets OH2. I'm just going to swap them around to have my rough work at the top. So it's going to be HCl reacting with Ca brackets OH2. Remember, we need the brackets because we're multiplying this hydroxide ion by 2, i.e. we need 2 of them. So that forms calcium chloride. So for this we go back to our rough work. Calcium again is Ca2+ ion, chloride is a Cl- ion. So for this one, calcium gives away 2 electrons, each chlorine can only accept 1, so therefore we need 2 chloride ions, and the formula becomes CaCl2. And the formula for water we all know is just H2O. For covalent molecules, if you're trying to work out the formula, you can either memorize them, or else you have a look at the group they're in the periodic table, have a look at the valency and see how many covalent bonds they're going to form. For more on covalent bonding, see the covalent bonding video. Okay, so what we've done there is we've gone through the first rule of balancing the equation. We've made sure we've got the correct formula of each species. So just to write it out, write the correct formula of each species. We know we've done that. Now, the law of conservation of mass for chemical reactions states that for every atom that you have in the reaction at the beginning, the same atom must exist at the end. Whether it's a gas that's get released into the atmosphere or not, you still start with a certain number of atoms of each element and you end up with the exact same number of atoms of that element. So the next step is literally to go through your species to make sure you've got the same number of each element. And the key thing is, you do not write in a subscript number or a small number. We've already got the chemical formula correct. If you write in a small number beside this, all you're doing is getting the formula for HCl wrong. So we make sure we don't do that. So I'm just going to write the second rule here just underneath. Okay, so I've just written that out there. Ensure there's the same number of atoms of each element on either side of the reaction. Okay, I'll start by looking at the reactants. There's 1, 2, 3 hydrogens on the left-hand side of my equation. There's 2 hydrogens on the right, so something is going to have to happen there. There is 1 chlorine in this molecule and 1 chlorine on the left, but there are 2 chlorines on the right-hand side. I need to have another chlorine on this side. To do that, we multiply this entire thing by 2. Remember, as I said, you can't include a small 2 just to include 2 chlorines. Whenever you're ensuring that there's the same number of atoms on either side of the equation, we just need to put a big number 2 in front. So this 2 means there are 2 molecules of hydrogen chloride. For more on that, I did go through that in a previous video in covalent bonding. So I've got 2 hydrogens here, and I've got 2 here, that's 4, but I've only got 2 here. What I can do now is double this up to create 2 waters over there. So 2 hydrogens and 2 hydrogens is 4 hydrogens, 4 hydrogens on the right as well. I've got 2 chlorines here because there's 2 there, and I've got 2 chlorines there, so my chlorines are even. I've got 1 calcium and I've got 1 calcium on the right as well. I've got 2 oxygens here, there's 2 there, and I've got 2 oxygens there as well. So there you go, that equation is balanced. because I've got the same number of atoms of each element on either side of the equation, so it's balanced. I'm just going to write in the last rule that you can only change the number of atoms after you corrected the formula by putting a large number in front. So there we have it, a balanced equation according to the rules that we've created there. Let's look at another equation now. Acid plus metal goes to salt plus hydrogen. Okay, so we're going to look at sulfuric acid and lithium, for example, to produce a salt and hydrogen. So sulfuric acid plus lithium react to give the salt and hydrogen. To create the salt, we know that lithium is the metal that's used, and the other part of the salt, the negative ion, will be the negative ion, the acid that we started, which is a sulfate. So the salt is lithium sulfate. So now we're going to start with our rules. First one is we need to write the correct formula of each species. So sulfuric acid, well, the counter ion there is sulfate, SO4 2-, and we know an acid is a source of H+, so for every sulfate we need 2 H+, so the formula is H2SO4. Lithium doesn't change, it's just an element, so we just write down lithium. They are going to react to produce lithium sulfate. Well, the ion for lithium is Li+. Sulfite ion over here is SO4 2-, so we need 2 lithiums for every sulfate, so therefore the formula of lithium sulfate is Li2SO4. And hydrogen is just hydrogen, it's a diatomic molecule, H2. Okay, this one's quite a straightforward one. H2 over here on the left hand side matches with H2 there. What I'll do is with the polyatomic I'll just treat it together. Sulfate on the left, sulfate on the right, 1 lithium atom on the left, 2 on the right, so therefore I need to use a large number using my rules to create double the amount of lithium on the left, so that's 2 lithiums here and only 2 there, so therefore we're balanced. The last reaction I'll look at is a combustion reaction. So for example, if we had an alkane, for more on that, see the organic chemistry section, we'll look at ethane reacting with oxygen to produce carbon dioxide plus water. A combustion reaction is the burning of a substance in oxygen releasing energy. Okay, so it's a rapid reaction of a substance with oxygen which releases energy. Ethane reacts with oxygen. All organic fuels react with oxygen if there's enough oxygen to give carbon dioxide and water. It's really straightforward, okay? All organic fuels will react with oxygen to give carbon dioxide and water. If there's not enough oxygen present, we'll get partially oxidized products like carbon monoxide and soot, which is just carbon itself, but we're not going to worry about that now. So the chemical formula for ethane is just C2H6. More on that, see the organic chemistry section. Reacting with oxygen. Oxygen's a diatomic molecule, okay, O2. Reacts to give carbon dioxide, which is CO2, plus water, H2O. Now, the reason we chose the combustion reactions is because they're quite common, okay? When I react ethane with oxygen, the first thing I do for a combustion reaction is see, well, if I've got 2 carbons here, 1 carbon here, I need to double up on the number of carbons. So it's going to be 2 carbon dioxides here. Next, I'll look at my hydrogen. I've got 6 hydrogens there. I've only got 2 in water, so therefore I've got to multiply this by 3. Okay, so at this stage now we've got 2 times 2 is 4 oxygens here and 3 oxygens here. That's 7 oxygens on the right, and we have 2 oxygens on the left. Combustion reactions are one of the only ones that we actually can write in a decimal point or a half. So we got 3.5 oxygens, because it happens all the time where we get an odd number of oxygens on one side as opposed to the other. Now if I didn't want to write that, and usually I wouldn't want that, I wouldn't want a 3.5 in my reaction, what I'd do is I'd just double everything. Okay, so I would end up having 2 ethanes, 7 oxygens, 4 carbon dioxides and 6 waters. Okay, both reactions are balanced, both are absolutely acceptable, because as I said, with combustion reactions we usually end up having an odd number of oxygens on either side, at least half the time, so we just write in a 3.5. If you're not happy with 3.5, then you can just double everything to give 7, so you can have 2 ethanes, 7 oxygens, 4 carbon dioxides and 6 waters. So that's it for balancing equations. The most important thing here, remember the rules, write the correct formula of each species, ensure there's the same number of atoms, and only use the large numbers in front to balance the equation.